Welcome to FEA Journeys, an FEA Academy podcast dedicated to sharing the experiences of seasoned engineers who have achieved success through finite element analysis. In this podcast, we will focus on highlighting the personal stories and the professional path within the FEA domain, catering to both aspiring and experienced engineers interested in exploring practical applications and achievements in FEA. In this podcast, you're going to hear individuals from different sectors of the FEA industry, including FEA software company, FEA consultant, companies that design their own products using FEA, and companies offering engineering services. These interviews will showcase diverse backgrounds and career journeys within the FEA field. For this episode of FEA Journeys, we speak with Surendra Narayan. Surendra is the president of Versatile Engineering, and he uses numerical methods like FEA and CFD to help clients design better products. He has supported a wide range of clients, from individual entrepreneurs to multinational companies, and he worked in a variety of industries, including healthcare, energy, and transportation. He firmly believed that numerical methods can be used to design and build a brighter and more efficient future for all. Thank you very much, Surendra, for joining the podcast FEA Journey today. And I'm confident that your journey and insight will inspire and guide those aspiring to make their mark in the world of FEA. So thank you very much for being here.
Oh, my pleasure.
We have a range of topics to discuss today, but before we dive in the discussion, could you please start by briefly introducing yourself to the community, to the audience, please?
Yes, my name is Surendra Narayan, and I'm a mechanical engineering by training. And for the past 17 years, I've had my own consulting business where I've focused on some design work, but also FEA as well as some CFD simulation work.
Okay, excellent. And in which domain do you conduct those simulation works?
So the FEA work, which is what I'll focus on, of course, today, is primarily structural analysis associated with the sort of industrial work that tends to be available in my area.
Okay, excellent. So everyone has a starting point in their journey, and for many, it's a moment of discovery that sets the course of their career. So I'm curious, can you share with us how you first came across finite element analysis? Did you come across it by chance, or was it a deliberate choice?
What happened was we were taking a course in numerical methods.
Okay.
And in that course in numerical methods, we, of course, were given the basis, well, why is numerical methods important? And one of the first things, of course, that came up was, well, you need to understand numerical methods if you're ever going to use these sorts of advanced simulation tools. It's very important that you understand the basics behind these methods. And so that course I just found fascinating. And of course, it's very challenging, when you think about solving a real world problem that often has nonlinearities involved. And, you decide, okay, I'm not going to simplify this and assume it's linear. I'm going to treat it as a nonlinear problem. So how do I go about solving this in an efficient way? And so that's what led me into the simulation world.
Okay, so definitively you started with numerical methods, correct?
That is correct, yes.
Okay, and it was at university or at work, working on project, on concrete project?
It was part of the curriculum at university.
Okay, cool. In which university?
The University of Alberta.
Okay, Canada. Excellent. So yeah, very interesting to know that you started your journey by this. Uh, we know that, and I'm sure you know, FEA is a very powerful tool, but like many sophisticated technologies, because it is a sophisticated technology, it can be misunderstood. Okay, do you see what I mean? And for you, what are some common misconceptions you've encountered in your career about FEA, and how do you address address them?
The most common misconception is that it's easy, first of all, sort of just to get started. It's not that difficult. And then people seem to also think that the more money you spend on the software, the easier it's going to become to solve the problems. That's the most, I think, most common misconception. And I think the way you get around that is, for those of us who've been doing it for a while, there are simple examples you can show people. For example, the bending of a beam, which we all learn to analyze closed form in university.
Mhm.
And you go onto a sophisticated FEA program, you try to set it up the way you did analytically in school, and it doesn't solve.
No.
And most people are pretty surprised at that because they're like, well, why isn't it solving? I understand the load paths here. What's going on? And that's so I tend to use simple examples to show them you need to really think carefully. You need to understand the difference between a closed form solution and
Yeah.
a simulation and how you can run into problems, even with a simple problem like that. So that's
Yeah.
how I tend to get around that misconception is try to find simple examples that they can relate to so that they realize, oh, this isn't just about pushing buttons and applying things blindly. No, there's a lot more to that.
Yeah. I totally agree. And it is a problem with FEA. It is the fact that uh, a lot of things are hidden behind the software, and I think it is the reason why finite element analysis is not understood well most of the time, because most of the time people try to use a software before to do a real simulation. You see what I mean? Uh,
Yes, absolutely.
I'm pretty sure you have seen that in your career in FEA.
Yes, very much so.
People using software before to try to do a simulation before to try understanding what is behind the scene. So
Mhm.
it is a problem of FEA. But we cannot blame people because now the FEA software are so beautiful, so well done that it's easy to 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 yeah to how to say that to fall in the pitfall.
Absolutely. One of the other things I find that's helpful, Dominic, to deal with the misconceptions associated with using it is often when you spend a little bit of time and talk to people about the history of FEA and give
Yeah,
them some ideas to, for example, how long has a certain, let's say, solver been around and who originally developed that solver?
yeah,
And that solver is still in use today. And then you start to sort of put the pieces together and realize, hold it, this solver has been around for a long time, and a lot of very bright people have been working on it for decades
yes,
in order for you and I to use the software. And you have to be respectful of that. They didn't work on this for decades because it was easy.
no,
They worked on it for decades because it's very challenging and they want to make it better all the time. But
correct.
right? And so I think that's another way to get around that misconception is to let them know, look, some extremely bright people have worked on these things for a long time. And so
Yeah,
give it the due respect that it deserves.
that's a very good comment. And yeah, those bright people who developed those software, they did that to permit us doing complex simulation, because we don't use FEA to solve simple problem. As you said, for simple problems, we have the closed form solution. We use them. We use FEA to solve complex problems. So
Yes,
yeah,
absolutely.
thank you for that, Surendra. Very good, very good. So For those just starting their FEA journey, the journey can appear challenging, and drawing from your experience, what advice would you give to someone new to the field of FEA? And what should they focus on to build a strong foundation in order to do FEA for sure?
I think the first thing they should focus on is understanding closed form solutions, and in particular, understanding the assumptions that lead to the closed form solutions.
Okay.
Because what I find is people will often, they'll remember an equation. Oh, here's column buckling. I remember Euler buckling formula. And they'll just, plug in the numbers and give you an answer. And then you'll look at them and you'll say, but under what conditions does this equation apply? What were the assumptions that were inherent in deriving that closed form equation? And are those assumptions valid for this problem you're doing now? So I think the first step is to have a good, solid understanding of closed form solutions and the assumptions that are involved. Because as soon as those assumptions are no longer valid, well, the equation is no longer valid. So
Yes.
now that will, in my opinion, typically then lead you to some sort of, obviously you need some other way to solve it, which is probably going to then be numerical.
Yeah.
So I would say that's the first thing. The second thing is patience. You need,
I love it. I love
you
it.
need a lot of patience if
So
you
true.
want to become good at FEA. You and I both know what it's like to spend time and set up a problem and think about all of the boundary conditions and everything you do, and you run the simulation and you come back, and at least in my case, I can say, and then you look and you go, oh, I forgot to check gravity or
Yeah.
something like that. And you just have to be patient, because this is part of engineering that is part art and part mathematics.
Yeah.
And you have to appreciate that. And that's where the patience comes in, is because you can't learn and master this in a short period of time.
No.
It's not possible.
Yeah.
You learn slowly, iteratively, gradually, and often problems that you thought were going to be straightforward, you get through most of it, and then you hit that part where you're like, hold it. Is
Yeah.
this really a pinned connection, or is this really a fixed connection? Actually, I don't think it's either of those. So how am I going to proceed? Do I have to run two simulations where one is pinned and one is fixed, and then compare the results?
Yes.
How am I going to approach it? So patience is very important.
Yeah.
And the other thing that's extremely helpful is if you can have a mentor. It will bring you up to speed so much quicker if you can find someone who's gone through the journey and can act as a guide, because not only will they save you time, they will save you a lot of frustration.
Oh yes. Oh yes. Oh yes. I can only agree with you, Surendra, and I love what you said about patience. Okay. For sure, everybody can learn FEA, for sure, but it's not like that. It takes time. It takes a lot of practice, a lot of dedication to learn the details. Thank you for sharing that with the audience, because it's so fundamental. And I love also your point about mentors. For beginners, it's a huge advantage to have mentors to guide them through the process of learning FEA, because as you said, it's so vast, it's so complex that it's easy to be lost. Okay, and I agree. Having a mentor, it's a huge advantage.
Mm-hmm.
Yeah, great suggestion, great advice for the people who want to pursue a career in FEA. So success in FEA requires a blend of theoretical knowledge and practical skills, as we said before. Could you highlight the key areas of knowledge and skills that you believe are essential for an FEA engineer?
Um, Understanding numerical methods,
Yeah,
understanding the mechanics of deformable bodies,
good. I love it.
um, understanding again the relevant closed form solutions so that when you look at your problem initially, at least what I try to do as much as I can is I look at a problem initially and I will break it down so that I can come up with some sort of pencil solution to give me some idea as to what I think the system is going to behave like before I even do it.
Yeah.
And I think the other thing, the other area to be familiar with is understanding when people use the term nonlinear,
Hmm.
that you're very clear on which variables they're talking about. Because I know for myself in university, the professors would toss out the terms, it's nonlinear here, nonlinearity here. And I found it frustrating at times because, okay, if we're talking, let's say, about a material model,
Hmm.
then what is the variable on the y-axis? What is the variable in the x-axis? And now I can start to visualize what they're talking about in terms of, oh, it's stress versus strain. And
Yes.
therefore, if I see this, it better not be a straight line through the whole thing because that would make it linear.
Yeah.
Um, so that's the other thing. It's to me, it's kind of a subtle point, but it's very easy for those of us who are familiar with this to just say there's a nonlinearity in the system and here's how I'm going to proceed. But I think it's very, very helpful for the person, especially if you're mentoring them, to look at them and say, well, which variables am I talking about here? And can you sketch this? Can you sketch a graph here to give me some understanding as to
Correct.
what's involved?
Yeah, yeah, that's a good point. We know that nonlinear analysis is more complex than linear analysis. So what you say is very important to make sure that we understand the type of nonlinearity, because we can have different type of nonlinearities. We know that it's not necessarily material. It can be geometric, can be contact. So yeah, it's important to make sure that the parameters of the nonlinearity are essential. So in the same topic, the skills required to be successful in FEA. Do you think that at university there is a huge gap between the theoretical knowledge and the practical knowledge in learning FEA? Do you think that this gap exists, and what the university should do differently in order to avoid this huge gap between the two?
So first of all, I do agree with you that there is a gap. Now, having said that, of course, I did my training in university quite some time ago. So as to what is being taught now, at the moment, I can't speak to. But certainly when I took it, there was far more emphasis on the mathematics
Yeah,
and starting
which
with,
is important also.
which is very important. But again, you start, let's say, with deriving the stiffness of a spring.
Yeah,
And here's your force matrix, here's your stiffness matrix, here's your displacement, and start from there. And that's a very, very logical place to start. So we focused heavily on the mathematics and, let's say, deriving the stiffness matrix for different elements using different techniques, for
yeah,
example.
yeah,
But the time with the software in what I'll call the lab environment was really limited.
yeah.
And the problem was you were trying to learn how to use the software at the same time that you were trying to understand the FEA theory. And I
Absolutely
think a more efficient way to do it is to do it in a modular way.
correct.
So you, for example, say, okay, I want to teach people how to deal with using springs, let's say, in a model. So go ahead and teach that theory, but then give them the opportunity to model a number of systems with the software using the spring element. So you can reinforce the idea and they can see several problems associated with it before you then go on to it, let's say another element like beams and so on. So I think in my case, as I said, heavy in the mathematics, but definitely I left university knowing that there's a lot to learn to be able to practically apply it to solve a real problem.
Correct. Yeah, I agree with that, and I think this gap during my discussion with students, with many students, and also professors from university, I know that this gap still exists, unfortunately, and it means that in the industry, when we receive new engineers from new universities. We have a huge work to do in order to close the gap and to bring them at the industry level, let's say. And so it still exists. So we have to keep that in mind when we work with new people who are coming from the universities.
Mm-hmm. Yeah.
So now I want to talk about another thing about the client interaction, because we know that client interaction can be a crucial part in any FEA project because it influences both the direction and the outcomes. How do you manage the client's role in your projects, and what strategies do you use to ensure that their needs are met while maintaining the integrity of the analysis?
The first thing I try to do is, of course, meet with them and basically, get a sense as to what is the problem they're trying to solve and what is the outcomes that they really need to solve that problem. So I think and I love to have that interaction face to face because you pick up a lot of body language from the team. Because normally when I go and I meet with the group, it's not just one engineer on their side, it's three or four people from various areas of the company. So I find it very helpful to go in person, talk to them, and you get a sense as to, okay, what's going on here, who's involved, what's this person's priority, what's that person's priority from this analysis. Now, having said that, once I do that, what I then try to do is establish one point of contact for the work, if I can.
Okay.
And that is straight from experience, because it can get very frustrating when you're expected to, let's say, communicate your results to several different people. It's very inefficient.
Correct.
And so I try to get that single point of contact in order to try to smooth out the process. And in addition to that, as far as managing, I guess, the client relationship, I also make sure that at critical stages of the analysis, things are signed off.
Mm-hmm.
So they understand, okay, this is a major milestone. You've presented me a model that was designed, modeled by your modeler in-house.
Mm-hmm.
And this is important. So you need to sign off on this. Let me know, yes, this is the model you want me to go ahead and look at and start the process with. And it's also things as simple as, let's say, sending material certifications. So let's say they built a prototype and they have a mill cert for the material that they actually used. Well, I'd like a copy of that mill cert because I'm going to use the information on there for my inputs for my material properties and things like that. So I think that's how I try to do it. But I think the real key to me, Dominic, is if you can establish a one-to-one relationship as you're working through the project, let that person deal with the team on their side as they need to provide input to that individual. But for me to be able to just contact and deal with one person, I think streamlines the process a fair bit. What are your thoughts?
Yeah, makes sense. I totally agree with that. This one-on-one interaction. It is fundamental for the success of an FEA project. And as you said, to summarize, this client interaction is based on communication. It is the key point that the audience should recall. It is we as FEA engineers, we are not working in silo on our side doing just a simulation. We have to communicate a lot with different experts, different stakeholders. But I totally agree with you. Dealing with only one person, a focal point, it is the key of the success. Yeah.
Yeah, I think it's helpful.
Yeah. We know that every engineer has that one problem that stands out, a challenge that pushed their skills to the limit. Can you share a story about a particularly difficult engineering problem where FEA played a key role in finding the solution? You see what I mean? We were all involved in project where FEA was so important, for the success of the project. Do you have such a story to share with us?
Yeah, I do. So another engineering company had designed some equipment for the client, and it was not responding and behaving the way that they wanted it to. So they brought me in to take a look at what was done, and the response of the system was quite odd. And
Okay.
so the first thing I did was I said, well, first thing I got to do is I got to figure out why it's doing what it's doing. And it was fairly complicated in terms of the actuation that was involved, the loads that were involved, the geometry that was involved, and so on. And so it took me a while to figure out essentially what had gone wrong in the design that they had done.
Okay.
And once I was able to establish, okay, now I understand why the response of the system is the way it is, and I was able to actually track it back to, by talking to enough people, I was able to sort of figure out, oh, they almost literally, Dominique, put one of the components on backwards, essentially, changed the overall location of the center of mass, and that had a lot to do with why the system was behaving the way it was.
Okay.
And part of what I found in my analysis is when I went through the drawings, is it was very easy to see how they ended up putting on the component incorrectly in the wrong orientation.
Okay.
So
You mean in their simulation?
I'm sorry?
You mean in the simulation?
No, not in the actual build of
In the design?
in the actual design of the
Oh, okay,
product.
okay,
So
okay,
as the product was sitting in the field in front of me and I was trying to figure out the behavior, once I traced it back, I realized, okay, well, that component over there was actually supposed to be in a completely different orientation.
okay,
And
okay. I
so,
see what you mean.
right. So once I was able to then go through and simulate that and replicate closely enough what had happened, that's when everything came together and it became clear, okay, here are the errors that were made in this design, or in this case, the assembly, the actual fabrication. And what I needed then to do, they wanted it changed completely because one of the problems was this platform that was lifting was not lifting perfectly horizontal.
Okay,
There was a slight slope to it. And so I was then able to build my new model and then use FEA to verify, obviously, that the displacements were appropriate, the stresses, the strains, etc. But was then also able to ensure that, that the platform should stay level through the range of motion that I was sort of looking at for it. So I think that was one of the more interesting problems I had. And I think the reason is because when you see a large piece of equipment in front of you that was designed and fabricated and it's right there, and you see something's not working correctly, it's and it's not obvious as to what the problem is, then you've
yeah,
got to start digging, and then you start asking yourself questions like the other engineering company, or why did they do it this way? Or why am I seeing that? And I didn't have access to them at all.
Oh,
So
yeah.
it was it was very much an investigation to kind of, I was going to say reverse engineer, but there's something about that term bothers me. but I basically needed to sort of figure it out. But I think the reason I bring up this project, Dominic, is because something's in front of you. It's been built, and there's a sense that you want to say, okay, there's got to be good reason why it was done this way. They
Yeah.
can't, there's got to be good reason. And
Yeah.
yet you're finding mistakes. And then as you find mistakes, you start trying to ensure that you're right that about those mistakes.
Correct.
And you then need to have the ability to use these tools, for example, to make sure that yes, you're right, and you can show this is the error and why it's occurring. So to me, that was one of the more interesting projects that I.
Yeah. Yeah, that's a good example. I love it because here you demonstrate that FEA can be used also, okay, to find a solution, but also to demonstrate that an existing solution is not working. You
Yes.
see what I mean? So you
Yeah.
start with what is existing, you run the simulation and you show that it's not working. Then you modify the design, so you modify the simulation, you run again, and you show the improvement without building any new system. So
Exactly. Exactly. Without going to the expense, as you said, of actually fabricating and
I,
welding and doing all of that work.
correct, correct. Yeah, that's a great application of FEA. And for us, for FEA engineers, it's really cool to arrive in such a situation and to improve the design just by manipulating simulations. That's very good.
It was a very rewarding project. That's
Yeah, yeah, yeah. I can understand that.
yeah.
FEA has revolutionized the product design and the development of the product, but across various industries. Okay, so we were not from the same industry because me I am in the aerospace industry, but FEA is a revolution for all the industries in the world. From your perspective, how has it changed the way the products are conceived and brought to market, but in your field? I don't want to you talk about aerospace, but in your field, how it changed the way the products are designed.
It has made the design process much more efficient for those companies that accept it. There's been a lot of very traditional build and break attitude in some of the industries that I've worked in.
Yeah.
So the feeling is we just made something, we tried it, it broke. So let's make it bigger.
Mm.
Let's make it taller. Let's make the wall thicker without understanding why did it break.
Mm.
And so I think it's been extremely useful to be able to go to those companies when they've had a failure and say, hold it. Before you go to the expense and time of you're assuming the problem was the wall thickness and you're now going to just make it bigger, build it again and try it again. Maybe we should sit down and try to understand why it actually failed. And many times they're surprised when they see the failure didn't have anything to do with the fact that the wall wasn't thick enough.
Yeah.
It could have had to do with their manufacturing process. It could have had to do with surface finishes that weren't being met. There were all sorts of other possibilities. And so that's probably the number one thing I've noticed in the areas I work is for the companies that accept it, they start to realize, oh, that's right. Just changing the material and making it bigger and making it stronger or whatever their perception is of what the better design will be, they start to realize the truth is they were guessing.
Yeah.
That's it.
Yeah. Exactly. Without understanding the real behavior of the system of the structure.
Exactly. Exactly.
Yeah, 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 yeah. Good point. We we do the we with our analysis we reach this, we capture this behavior. It is the beauty of simulation of finite element analysis. It is the fact that we can capture the detailed behavior uh, as soon as we use the proper modeling techniques, for sure, and we do the right assumptions. But it is the beauty of FEA.
Yes, absolutely.
But as a FEA analyst, to continue on the topic, as a FEA analyst, the work doesn't end once the analysis is complete. You see what I mean? Because in our work, and especially for you as a consultant engineer, reporting is a critical component of the FEA process. I'm pretty sure you agree with me, Surendra, that this reporting is very important. So, in your experience, how important are the reports produced after an FEA analysis, and what role do they play in the overall project? Okay, when I say the overall project, I'm talking about the analysis of the structure of the system.
So the reports are, number one, they're very important because they're obviously, the purpose of them, of course, is for someone who has a suitable background on the other side to be able to go through and basically see, how did you solve this problem? And you and I both know there's a lot of details along the way in terms of element selection and meshing quality and justifying boundary conditions and so on. So the reports are very, very important. And I would also add that the reports themselves often take much more time than doing the
Yes,
actual analysis. And
absolutely.
that is also something that I would let new FEA engineers know is, don't be surprised that you learning how to solve the problems is a lot of fun and it's challenging. But when you then have to sit down and write a report for your manager, for example, and justify the entire analysis from top to bottom, don't be surprised if you spend, I don't know, 2 times, 3 times, 4 times, 5 times as much time writing up the report.
Absolutely.
And of course, once you do that, people are free to question you on the decisions you made and the way
Sure.
you did things. And so don't be surprised if they come back and say, well, we're not sure about this particular boundary condition you selected. We think you should try this instead. Don't be surprised if that then results in you having to go back and do an iteration. So
Yes.
reports are very important. The other thing I would say, Dominic, is the first thing is, when you're writing the report, of course, you have to know who your audience is, right?
Yes.
Because if you're writing it for someone like yourself, who's an expert in FEA and aerospace, well, you better dot your I's and cross your T's because you're going to pick up if there are problems. If, on the other hand, it's being submitted to someone who says, I just want to see the deformations, I'm not concerned about anything else, then you as an analyst need to be very careful, because if you just provide them what they want, are you actually fulfilling your obligations as an engineer?
Mm. Yeah. 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 It is true what you said, Surendra, about the time we spend to write those reports. It's a lot of time. But it's needed because we have to document the analysis, the assumptions, the results. But I see another usage of those reports. I think it can be used also to educate people about FEA, because we put a lot of information into those reports. So when another engineer take the analysis, he learned by just reading our report. He learned all the assumptions we did, and maybe it can be an engineer who doesn't know all the details about the modeling techniques, and he can learn something about how to model the structure a system thanks to the report. So it's very important. We spend a lot of time in writing good report, complete report about our analysis. Totally agree.
I would also add too, Dominic, that's of course, as you know, for regulatory bodies,
Yeah,
don't be surprised if they are very demanding when it comes to a report.
sure.
You and I both know that. So,
Yeah,
writing a report perhaps for a local client, it needs to be thorough, but it's, again, if it's for a regulatory body, they'll often tell you exactly what they want to see in the report,
yeah.
right? They'll lay it out for you and say, these are the sections we must have in the report. And of course, it's your job and my job to try to satisfy that and submit it, because they're the ones who are going to give final approval on the
Absolutely.
work you've done. So that's something that I think engineers also need to be familiar with, is regulatory bodies that might be looking over your work later.
Yeah. Very interesting, very important point. Thank you for mentioning it, Surendra. Yeah, that's true. Time is running, so but I have one last question for you, one last topic for you, Surendra, if you don't mind. As we said before, FEA is not just a tool, okay? To me, it's a career-defining skill that can shape both personal and professional trajectories. So, reflecting on your journey, how has working with FEA influenced your growth as an engineer and as an individual?
One of the things it does is it keeps you humble because you realize how much you still don't know
Yeah,
after years of studying problems and trying to solve them.
yeah.
Um,
And there is always a lot we don't know.
there's so much. There's just so much, and I think so. That's a good thing. It's good, and
Yeah,
it keeps you humble, but also keeps you hungry, because you still want to continue to learn more, and especially to be able to use the tool for a wider variety of problems,
hmm,
because that's very interesting. So I think those things are both, you learn those professionally, but I think it helps you personally as well. Um, as soon as it kind of, to me, it kind of ties into, I think it was something Einstein said, where someone asked him, if you had a half an hour to solve a problem, how would you do
yeah,
it?
yeah,
And I think early in our careers, well, I'll speak for myself, maybe there's a tendency to want to kind of jump in a little bit quick and just kind of get going on the problem and get it solved. And I think what one of the things FEA teaches you is, and Einstein's answer, by the way, was he spent 25 minutes thinking about it and then 5 minutes solving it. And I think
mm,
there's something about FEA that leads you to that same sort of approach,
correct.
that you sit down and you say, you know what, I've got a problem. Yeah, it's really easy to click and apply a boundary condition here, and it's really easy to click and apply a material here. But have I really thought through what this problem is about? Should I be applying the Einstein approach and saying, hold it, maybe I should be spending a lot more time thinking about the problem and setting it up, pencil, paper, before I start anything. And I think that's something that is also good personally and professionally, is I don't think that you ever waste time if you try to think using a lot of effort about a problem.
Yeah,
Effortful, if that's a word, effortful thinking
mm,
is well worth it.
yeah,
I think FEA teaches you that.
yeah. Yeah, very good points, Surendra. Yeah, totally agree. So thank you so much, Surendra, for taking the time to share your experience, your knowledge, and journey in the field of finite element analysis with us. I'm sure that your insight and stories provide, I should say, invaluable guidance for those who are looking to pursue a career in the domain of finite element analysis. And I'm sure that the audience will find your perspective both inspiring and educational. So we look forward to seeing you all in the next episode of FEA Journeys, where we'll continue exploring the fascinating world of FEA with more incredible professionals. Thank you once again, Surendra, for being part of this journey with us. and bye-bye.
Thank you very much. Appreciate it.